Good morning, my name is Rivaldo Tanbung and my partner is Christiawan, Rianky, and Evaluatus Didik Madhya Maja. Today, I will present our research title, Explaining Sentiment Analysis in Digital Design, a Machine Learning Approach to Analyzing User Perception of Canva. This research was conducted as a team project under the guidance of our faculty advisor. Agenda. First is introduction, second is ritual review, third is research method and materials, fourth is result and discussion, and the last is conclusion. Introduction. Canva has over 135 million users worldwide as of 2023, with millions of new users joining each month. Key features. First is drag-and-drop design tools, customizable templates, and collaborative editing. User reviews play a crucial role in improvising features, identifying bugs, and enhancing user satisfaction. Problem formulation. First is what does the majority opinion of Google Play Store users think about Canva, especially regarding recent policy and feature changes. And second is how can sentiment analysis be applied to Indonesian language? Review of Canva to extract actionable insight for improving user experience and guiding product development. Problem scope. The data used in this research was collected from Google Play Store user reviews. The data collection method involves data crawling using Python with a custom Google Play scraper. The study used three machine learning algorithms for sentiment classification. First is support vector machine, nearest neighbor, and random forest. Research objective. Analyze user sentiment towards Canva, especially regarding policy change and new features. Second is identify the most effective machine learning algorithm for classifying Canva user reviews. And third is provide insight to help Canva and similar apps developers improve product development and user experience. Literature review. First is sentiment analysis, used to classify user opinion into several forms, which is positive positive, positive negative, negative negative, and negative positive. Second is SVM, excels in efficiently handling unstructured high-dimensional data like image, offering simplicity in interpretation and better scalability than text-based model for classification tasks. Tandem forests use multiple decision trees to improve accuracy, handle missing data, controlling overfitting, and excels in complex noisy data sets with customizable parameters. Nearest neighbor is a simple, powerful algorithm that classifies data by close proximity, excelling in irregular boundaries and real-time use. Methodology. Steps taken include data collection. We collected 5,000 data from Google Play Store to be used in this sentiment analysis. Data labeling, we labeling the data to positive, negative. Data cleaning, first is text processing. We convert all the text into its forecast form, removing unwanted character with removing any irrelevant character. Normalization, we normalize the words of each data into correct form. Stop word removal, we removing any stop words. Stemming, we simplify the content of the data into its most simplified form. Splitting, we group the data into two groups, which is 80% as simulation data and 20% as test data. Result. Random forest based on the sentiment analysis and the 20% of test data that is inputted into the algorithm, the results are 39 negative negative, 49 negative positive, 13 positive negative, and at 199 positive positive. SVM or SVM based on the same 20% of the data inputted in 44 negative negative, 44 negative positive, 14 positive negative, and at 198 positive positive. The nearest neighbor, lastly, the result of the KNN algorithm is 9 negative negative, 79 negative positive, and 2 negative positive negative, and 110 positive positive. Top 10 positive fault. By applying the word cloud visualization method, we can observe the frequency of each word in the sentiment analysis. The larger the word appears in the cloud, the more often it is mentioned in the data. Below are the top 10 most frequently occurring positive words identified. Top 10 negative words. By applying the word cloud visualization method, we can observe the frequency of each word in the sentiment analysis. The larger the word appears in the cloud, the more often it is mentioned in the data. Below are the top 10 most frequently occurring negative words identified. Conclusion. First, this research compares various metrics for the three model classification used is random forest, SVM, and Kinner score. Second is the result obtained from this research in the highest accuracy is SVM at 94% or 94.2%, and the second highest is random forest at 94% or 93.8%, and lastly, Kinner's neighbor with 92% or 91.1%. And the third is the top 10 words in the both positive and negative is visualized by using words and chart to better visualize the user sentiment analysis. That's conclude my presentation. I hope this research contribute to a better understanding of how machine learning can be applied in analyzing user reviews. Thank you for your attention. I'm open to any question. Thank you.